Today we're reviewing Unit 3. So the first question, identify the hypothesis and conclusion of the conditional statement. An angle is obtuse if it measures 170 degrees. So remember that the hypothesis follows the word if all the time. That means that in this statement, our hypothesis is it measures 107 degrees. And that means that our conclusion is an angle is obtuse. Notice I did not say anything about if. Hypothesis is its measure is 107 degrees. Conclusion is an angle is obtuse. Next up, we want to write a conditional statement for the Venn diagram, which means we need to identify our hypothesis and conclusion in our Venn diagram. And our hypothesis, remember, is the smaller oval, which means it's the squares. Our conclusion is rectangles, our larger oval. And then we need to remember what, in general, we're talking about. And squares and rectangles are both figures. And remember that we start with our general, then we go to our hypothesis, and then our conclusion. So we'd have if figures are squares, then they are rectangles. So again, if figures are squares, then they are rectangles. Next up, we want to write our converse, inverse, and contrapositive from the following conditional statement and determine our truth value. So our conditional statement is if a number is divisible by 3, then it is divisible by 9. What is our hypothesis? A number is divisible by 3 because it's after the word if. That is our hypothesis. And then our conclusion is it is divisible by 9. Because remember, we do not include the word then. Now we need to write our converse. Remember that our converse flips our hypothesis and conclusion. So we would have if a number is divisible by 9, then it is divisible by 3. Remember that we don't start our sentences with a pronoun, so we aren't going to start with if it. We refer to what it means, which is a number. So if a number is divisible by 9, then it is divisible by 3. What is our truth value? It is true, because if you give me a multiple of 9, 9 is divisible by 3. So anything that multiplies by 9 is divisible by 3. So our truth value is true. Now we need to write the inverse. Remember, the inverse takes the original order and negates it. So we'd have if a number is not divisible by 3, then it is not divisible by 9. So again, if a number is not divisible by 3, then it is not divisible not by 9. What would our truth value be? So if a number is not divisible by 3, then it's not divisible by 9. So remember that 9 is a multiple of 3. So if you can't divide your number by 3, then you can't divide your number by 9. So that's a true statement. Then we want our contrapositive. Remember, contrapositive takes flips and negates. So we'd have, if a number is not divisible by 9, then it is not divisible by 3. Again, our contrapositive, if a number is not divisible by 9, then it is not divisible by 3. So let's say we had 12. 12 is not divisible by 9, but it is divisible by 3, so this statement is false. Next up, we want to identify each of the following. The first one is a pair of parallel segments. And there's only 2 segments that are parallel because there's only 2 that are marked with arrows. Those arrows tell me that those segments are parallel. So we have segment JK and segment HL. Yes, they need to be in that order because your congruent corresponding parts have to match. Next up, we want a pair of perpendicular segments. So we only have one right angle box marked. That tells us that that's a pair of perpendicular segments. So our perpendicular segments would be segment JK and segment HJ. And then we want a pair of skew segments, so it doesn't really matter what I put down for the first one, so long as the second one is not parallel with it, is on a different plane than the first one that I put down, and doesn't intersect it. So if I put down segment HL, this top one, I don't want anything that's on the same plane with that segment. I don't want anything that intersects it. So I could put down segment KN. Could also have said segment JM, or segment MQ, or segment NP. Next up, we want to identify the transversal, meaning the line that's going through 2 or more other lines, and classify each angle pair. We are first looking at angles 5 and 3. So angles 5 and 3 are both on line Q, so that makes line Q our transversal. And notice they are on different sides of line Q, that makes them alternate. And they are in between the 2 lines that are being intersected. That makes them interior angles. Our next set, we are looking at angle 2 and angle 4. And angle 2 and angle 4 are both on line R, which makes line R our transversal. And angle 2 and angle 4 are both on the same side of line R, but one is in between the 2 lines that are being intersected, and one is outside, which makes these corresponding angles. And then next up, we're looking at angle 5 and angle 1. Angle 5 and angle 1 are both on line P, which makes line P our transversal. And angles 1 and 5 are on different sides of our transversal, which makes them alternate. And they are on the outside of the lines that are being intersected, which makes them exterior angles. Next up, we want to use our figure here and determine each angle measure. So, let's look at what we know. We know angle 4, because angle 4 and 118 are alternate interior angles. So angle 4 is 118 degrees. We know angle 1 because angle 1 and 118 degrees are corresponding angles. We know angle 6 is also 118 degrees because those are vertical angles. Then we can take and subtract 118 from 180. And that gets us angle 2 because those are same side interior angles. And that gets us angle 3 because angle 2 and angle 3 are vertical angles. And we know angle 5 is also 62 degrees because it makes a linear pair with that 118 degrees. And angle 7 is a vertical angle with angle 5. And it also makes a linear pair with that 118 degrees. Next up, we're looking at 15x and 2x plus 17. And we have parallel lines being intersected by a transversal. And these are on different sides of our transversal and in between the two lines that are being intersected. So these are alternate interior angles. And what do we know about alternate interior angles when the lines are parallel? They are congruent, so we can set these equal to each other. So 15x equals 12x plus 17. Subtract 12x from both sides. So we'd have 3x equaling 17. Divide both sides by 3. So we have x equals 17 thirds. On our next one, we're looking at 9x minus 6 and 3x plus 18. These are on the same side of our transversal, and they're both interior angles, so these are same side interior angles. And what do we know about same side interior angles? When the lines are parallel, they are not congruent, they are supplementary, they add to equal 180 degrees. So that's what we're going to do. We're going to add 9x minus 6 plus 3x plus 18 and set it equal to 180 degrees. Now we're going to combine our like terms. So we got 12x plus 12 equaling 180 degrees. We're going to subtract 12 from both sides. So we have 12x equaling 168. Then we're going to divide both sides by 12. And x equals 14. Next up, we want to name the postulate or theorem that proves that line P and Q are parallel. First off, we're looking at angle 8 and 1 being congruent. And these are on different sides of our transversal, which makes them alternate. And they are outside of the lines that are being intersected. So these are exterior angles, so alternate exterior angles. Then we're looking at angles 2 and 4 being congruent. And these are on the same side of the transversal. One is inside of the lines being intersected, and one's outside of them. So that makes these corresponding angles. And then we're looking at angle 2 and angle 3 adding up to 180 degrees. So angle 2 and angle 3 are on the same side of the transversal, and they're interior angles. So these are same side interior angles. They are also the only ones that can add up to 180 degrees. Number 18, we want to solve for x. So we know that this angle is 90 degrees, which means that all the other angles around it are also 90 degrees because our two lines intersect. All of those angles are right angles. And because these lines are perpendicular to, or parallel, we know that the other set of lines is also perpendicular. That means that 9x equals 90. Divide by 9, and x equals 10. And the last one, the designer is adding ribbons to a dress, creating the angles shown, which the angle measures would ensure that the ribbons are parallel. The first one is that angle 3 and angle 4 are equal. So angle 3 and angle 4 are same side interior angles. And they typically add up to equal 180 degrees. So that could be true, but it's only true in one case. So that's a maybe. Then we have angle 8 and angle 1 being equal. That only deals with one set of those lines, and those are vertical angles. That doesn't tell me that the green ribbons are parallel to each other. So we know it's not that one. Then we're looking at angle 1 and angle 4. Angle 1 and angle 4 are on the same side of the transversal. One's outside and one's inside though. And those are corresponding angles. And corresponding angles are congruent. So that could be my answer, because that's all the time that those would be equal. Then we are looking at angles 5 and 7. And angles 5 and 7, those are vertical angles. So we know it's not that one. So our answer is C, because that one happens all the time.